What's going on, everyone? This example exercise problem, call it whatever you want, is very, very simple. I promise, super simple, okay? And we're gonna solve it rather quickly. Let's get right to it. It says, Carla Ayala is playing tennis. As the tennis ball is approaching Carla with the speed of 30 meters per second, she hits the ball and it moves back to the direction of her opponent, that is, the opposite direction, with a velocity of 33 meters per second. If the racket and the tennis ball were in contact for 0.05 seconds, what is the magnitude of the force exerted on the ball? Assume the mass of the tennis ball to be 55 grams. So what's happening is a very simple situation, right? Um, and what I want you to focus, although we have many ways to solve this one, right? We could use, since we're looking for force, what is the magnitude of the force? There's various ways in which we can find force. But for this one, since we have been talking about momentum, changing momentum, we're going to use just that, change in momentum, okay? And so let's write down the given. Well, before we write down the given, here's the moneymaker, guys. Here's the moneymaker. It moves back to the direction of our opponent. That is the opposite direction. Okay, this is the moneymaker here. Okay, this can make or break your problem or your solution, right? Let me fix my writing pad. There you go. So let's start writing down the given. So we're going to have a speed. Now we're going to call this velocity initial, so V naught, 30 meters per second. There you go. And then we have another velocity of 33 meters per second. Now, it says to the direction opposite to the right to Carla. The fact that these two velocities are opposite, or well, we have to show that with numbers by means of a negative sign because one has to be in the opposite direction. Now, we are not given an angle. That's very good. So we don't have to do any trigonometry. We're going to assume everything happens horizontally, right, on the same axis. No angles. And it really doesn't matter which one. Oh, wait, I wrote V not for both. This is V final. It doesn't really matter which one you make negative because you need to find the magnitude. So even if you get a negative number, you just want the magnitude that is a positive number. Okay? And I will say that a tennis ball coming towards you is negative, right? Because maybe you're not prepared for it. So we'll call this one negative, and there you go. Now I'm showing that they have opposite directions with this negative sign. Okay, let's keep going. We have a time of contact of 0.05 seconds. Now for these problems, guys, if you want to write down the time of contact by delta t, that is perfectly fine because we're assuming time initial to be 0 when the contact starts, and then when they're no longer in contact, that's the final one. So delta t is still 0.05 seconds. And then we're trying to find force, and we were given the mass. And of course, I'm hoping you guys notice that this is in grams. We want kilograms. Kilo, that prefix. Don't forget about Instagram, right? So 3,000 followers is 3K, or 5K runs, that is 5,000 meters. So a kilogram is greater than a gram. That is this number. Or when we convert this into kilogram, we need to get a smaller number because a gram is less than a kilogram. Kilo, 1,000, 30. So I moved the decimal point 3 places to the left, right? So 1, 2, and then I add a 0. So it'll be 0.055 kilograms. If you don't believe me, you can check, right? We have 55 grams, and we know that there is 1,000 grams per kilogram. Come on. There you go, 0.055. And we need to find the force. And we have to change the momentum. Some of you might know already what we need to do. Like I said, this one is super simple. And let's start with momentum. Momentum is a vector, right? And then you have mass times velocity. I'm just going to add the vector symbol for this one. After that, I'm not going to, but please know that it's a vector. So change in momentum, in this case, so we can have either a change of mass or change in velocity. In this case, we're going to assume that the tennis ball is 55 grams before and after the whatever you call this one, right? Hitting the tennis ball. I don't know the tennis terminology. So the only thing that's changing is the velocity, which means that mass remains constant, and the only thing that's changing is velocity, delta v. And we know that delta v, change in velocity, is velocity final minus velocity initial. This is the change in momentum, okay? And we also know that the second, extension of the definition for Newton's second law of motion, as we know force equals mass times acceleration, we also said that force equals the change in momentum divided by the change in time. If you ever forget about this new or different version of Newton's second law of motion, the equation for impulse, I'm just going to write it down so you can see it. It says that force multiplied by delta t is equal to change in momentum, because impulse changes momentum. So if I divide this by delta t, because I want to know the force, this is a very ugly delta. Look, force equals delta p divided by delta t. Okay, in case you forget, you can use impulse. And now I'm going to combine this one and this one to have force will be equal to change in momentum, that is mass times velocity final minus velocity initial divided by the change in time. And I have all of these. I don't have to do any algebra. I know, right? How boring. But sometimes we get problems like this, and I guess sometimes boring is okay. Mass is 0.055 kilograms times, I'm going to need brackets. Oh no, well, yes, I'm going to need brackets. We'll see why. Let's try that one more time. Maybe that's a little better. Times final velocity, 33. Wait, I don't need the parentheses yet. 33 meters per second. Let me fix this one. I don't like it. 33 meters per second minus negative 30 meters per second. Oh no, I ran out of space. And you guys know I'm not going to draw this line because it's not going to be pretty, so I'm just going to use my tools. And the time is 0.05 seconds. Don't forget that a short amount of time will lead to a somewhat large force, right? And these two negatives become a positive. So now I will write the whole thing again. 0.055 kilograms times 33 meters per second plus 30 meters per second. I'm telling you guys, if you don't pay attention to this direct change of direction and then you show that and you're given by means of a negative sign, this is going to be a disaster, because if we had, let's say we forgot about the negative, well, we'll have 33 minus 30, so we would have a velocity here, right, after doing the math, of 3 meters per second. That's the change in velocity, and no, that's not correct. There you go, seconds. I know that this is going to be 63. We're still going to show it anyway. So right, we have double parentheses. So 0.55, wait, 0.055 times 33 plus 30 divided by 0.05, 69.3. Okay, 69.3, that is the force. 69.3 newtons. It's force. Hopefully you see that it's kilogram times meter per second squared. But just know that's Newton. Now, if we had picked this one to be positive, this one negative, this one would be negative 33 minus 30, so that would be negative 63, and our force would have been negative 69.3. Since we just won the magnitude, we still get just the positive number. Okay. The key to a problem like this, change in direction. Okay. Change in direction, show it by means of a negative sign. And that's it for this problem. So simple. So simple.